Hi, my name is Noah Gift, and today we're going to talk about how to containerize a greedy algorithm, put it into production with an AWS App Runner microservice framework, and also develop that inside of Cloud9. Let's go ahead and get started. Is to come up with a way that you can essentially figure out the shortest path for a list of cities. And so in particular, this code sample, we will run it in a second, but basically the idea is that you figure out the city start and the city end and the distance. Those are really the main variables here. And let's put this a little bit bigger. And in this first part of the code, what it does is it finds all of the unique cities and we just make a list of them. And then this is a component that adds a randomized start. And so the idea for a randomized start is that you would like to do a simulation so that when you run this over and over again, that you will be able to minimize the shortest distance. So if you always pick the same city and there was millions of cities, then you wouldn't get a different solution for the greedy algorithm. But if you randomize it, you may not have time to go to all of the different combinations. In fact, it may not be possible, but you could get a good enough solution. And that's really the idea with the greedy algorithms, is that you want to do a simulation and figure out a good enough solution. And in this particular piece of code, we figure out the shortest path. And then this is the part that goes through and selects the next path to travel based on the shortest nearest path. And then we get the total distance. And then what we do is we say, let's figure out the lowest run of, let's say you did thousands or even millions of simulations. You just figure out the shortest path, and then that's a pretty good route. It doesn't have to be the perfect route. It's just a good enough route. And so this is really the gist of it. And if we look at the cities, I think this is the data set. Let me look at the data set here, which would be, here's this, and the routes is right here. So this would be a kind of a good example if you wanted to code this up yourself and in fact pick any set of cities. It could be, it could be in, this one happens to be in the Bay Area, and this was tech companies. So Apple, Cisco, Apple, CVX, Apple, eBay. These were just the stock symbols, but you could pick any city in any location around the world, maybe in Asia somewhere or in Europe or whatever, and you wanted to pick millions and millions of cities. You would just get the distance between each of these cities, put them into a list like this, and then once you've got this set of distances, then you're ready to do the simulation. So this is intentionally pretty small. It's not too big, but again, what's nice about this is that I can do these simulations. So let's go ahead and let's actually run this. So I'm going to go to code, and I'm going to use this thing called Github Codespaces, which is something I like quite a bit, because I can just take an example and then just run it in code. And by the way, for GitHub Codespaces, it is available for any university that uses something called GitHub Classrooms. So if you go here and you say GitHub Classroom, if your university goes through and registers for this, you can get free GitHub Codespaces. This is a kind of a new feature. I'll just give it to you. So if you want to ask your professor at your university to get something pretty cool, you can get this, and then it will give you access to what we're doing right here, which is GitHub Codespaces. So you get it for free as a student, which is, in my opinion, very nice, because you can just start building code solutions. You don't even have to worry about having a fancy laptop. You could have a very inexpensive laptop. You could even be building this on an iPad or a Android tablet and just have like a terminal like this, or like a keyboard, and you could just write all of your code inside of here. So I think these are very nice development environments. So what we'll do here is I'll just make this a little bit bigger. What I typically do when I check out a project like this is I like to create a Python virtual environment so that I don't have packaging issues. And so what I'm going to do here first is I'm going to say virtual env, and then I'll make a virtual environment. So that's really step one. And we'll go ahead and create that, and then I will source it. So we'll go through here and we'll say source.venv bin activate. And then once we source that, I can just say which Python, and you can see that I'm now using this. I'll make it a little bit bigger. I'm using now this virtual environment, which means that I should have less problems with packaging, because what I'm going to need to do next is look at this project, and I have some packages here. I have PyLint, NumPy, and I also have a formatting tool. And a lot of times what I'll do is I will build this all together in a Makefile. And the concept of a Makefile is almost like a bookmark for Firefox or Chrome or Safari, in that it just keeps track of a very long command, so I don't have to do it again. So for me, I should be able to just type in make install like this. And then once I do make install, it should install all the packages that I need for my project. And once we do that, then it's probably not a horrible idea for me to even do like a lint for one of these projects. So I think the traveling salesman problem was this. Let's see, which one was it? Greedy random start. So this is the one that I'm going to run. So maybe I should just check to make sure it's okay first. And so what I typically will do is I will add a lint step, which notice here it says greedy random start. This will make sure that this code doesn't have syntax problems. And so it's a kind of a good idea to do this. So we'll say make lint. Here we go. So we see that there's a problem. It says no module name TSP greedy random start. So that's the wrong name of the file. That's one problem. So let's go ahead and change this. And then if we do greedy random start, make lint, no module named greedy random start. Oh, because that's not the name of the file. It's called greedy random TSP. TSP, there we go. And let's do it again. Make lint. What is going on here? Let's just actually take this file, and let's just take the name, and let's just make the whole name here so that this lint step works. I don't know why that's not picking that up. It had hyphens. It had hyphens in it. There we go. Okay, that's a good sign. That's a good sign that it basically didn't find any syntax errors. Now let me show you why that's so important. Is that if I went to this file and I intentionally created like a bug. So let's say I went into here and I said, var equals, and I created some bad Python code. What this would do is it would stop this project from working. There we go. See, like it doesn't work. And the lint will even tell me line 19, there's a problem. So I think it is a very good idea for projects, especially for portfolio projects, to have some kind of a quality control step so that other people can access your code. So this looks good. This looks like I should be able to do this. And so now, again, I just run the make lint. It looks like it's good. And so can we actually run this? And so I'll look at the README and see how I did this before. So the way I did this before was that greedy random TSP, I said 10. So let's go ahead and try the same thing. Let's go through here and let's run this and let's see. Whoops. Let's go through here and go to, we'll go through here and say greedy random start TSP 10. And notice that it ran a simulation of 10 times. And it found that the shortest distance was 128. Now what if I did only 2 simulations? What would happen? Notice that because it's always random, it's going to start on just some random city, and there's no guarantee that it will come up with the correct answer. So imagine that it was more than we have. I don't know how many cities we have, let's say 20 or 30 cities. If it was 2 million cities, it may take a day for the simulation to run, or maybe it would take for a week. It depends on the data set, and it depends on the problem you're solving, because you could do this for other problems other than just cities. Like it could be anything where you have to figure out the minimum distance and you don't have the correct way to solve the problem. And so then it's up to you as the person who is in business analytics to say, well, how much time do I have, right? Do I have, how much time do I have to do the simulation? And then you just take however much time you have and you just run the simulation. The simulation, maybe it runs for a day, but the idea is that you'll probably find a good enough answer, right? You'll probably find a good enough answer. And then in this case, look, this 10 times it said, oh, look at this. We found a pretty good route. And then you would tell the people on your team, listen, there may be a better route, but we spent a day and we have something that's pretty good. In fact, if you remember before, we had a route that was longer and now we've actually improved it. And so that's really one of the nice things about the greedy algorithm. And in fact, if I do maybe more, if I did 100 simulations, right, we could do 100 simulations, see is still, it doesn't get any better. So that's why sometimes it's also good to have a cutoff, right, where you say, well, we after we've run 100 simulations or 1,000,000 simulations or however many simulations, we can't, right, if I say 1,000 simulations, it's going to take a lot longer, but it's not going to come up with a better answer, or 10,000 simulations, right? So I guess in a nutshell, the greedy algorithm approach can really be a nice tool to have in your toolkit when you're solving problems. And it is actually pretty straightforward to code up, because you just need to figure out a list of the cities, and you could plug this into this piece of code and build your own simulation, right? So you just need to go to the routes here and just put in your routes. That's it, right? So you can just download the routes from anywhere you want. So the other thing I would say for a project like this is that there is a tool called pip freeze, like this. And if you see this pip freeze, we may want to freeze this project so other people can actually look at the exact version of the package, because it's very common if you come back 3 years later that the people that developed maybe NumPy or Pandas or some other library, they may have changed things, and then someone on your team won't be able to run it. And so this is a neat little thing you can do, is if we go to NumPy right here, look, we see this. I can just go to the requirements file and I can just put in the exact version. So now we know this is locked in, right? We know that we've actually got this locked in to our project. And then we could do the same thing for the other tools. Here we see the library black. There we go. And then we also see PyLint. We can also lock that down. And so this just gives us a little more quality control so that I can give this to other people in the future, especially maybe somebody's looking at a job interview and they want to look at my project. If they pull it down and the libraries are not correct, they may think that you didn't write a good project when all it was the library was a newer library. And so what we can do in addition to this is we can also set up something that will automatically test this project so that we can be assured that it will work in the future. And this is often a really good idea for building software engineering projects. Even if you don't do a lot of coding, this is a good skill to have, and it's called continuous integration. And it could be really critical because, again, in the future, someone needs to run your project and they can't get access to it because the code doesn't work anymore. So how can you assure that there's quality? Well, if we go to, we just say get status here, this will show us what we've changed. And look, we've changed these things here, greedy random TSP, we've changed the requirements and we changed the Makefile. So let's go ahead and add those. So we'll go ahead and say add the Makefile. We'll add this, and we'll add the requirements. And then I'm going to say, freezing freezing my project. And then we can take a look at this inside of GitHub. So if we go back to this project, we can see that was the change I just made. But how do we test this so that it's got higher quality so it can be tested automatically? Fortunately, with GitHub, it's very easy. If you see this button here, Actions, you just click Actions. And then what we do is we say set up a workflow ourselves. And before I do that, let me just show you why this is really important for people studying analytics, is that you may need to do other things that require automation. And that's a lot of what we're covering is automation in this class, is that you may want to look at some of these other things like how to create and test a Python application, how to build projects with Make, how to use Python packaging with Anaconda, how to deploy to Tencent, or how to deploy to Ali Cloud, how to use Ruby on Rails or Swift, or do some other action. If you have time later, I think this would be a good thing to play around with. And if you're in product management as well, like I think many of you may go into product management, you can even do things like this. You can build automation around the labeling of projects. So you could, do some kind of labeling that says this is a feature, this is a bug. There's lots of automation that you can do here, because again, a lot of what we're covering is low code, no code solutions. So this is still pretty low code. I'm going to click this button, set up a workflow. And then I'm going to find another project I had that had an example of some PyTest things. Here we go, PyTest. You can take a look at this. I'll throw this into chat. But basically, this is a workflow I did before. I'm just going to copy this, and I'm going to use something similar for our project. So I'm going to go here and do this. And so the idea here with this is that we're going to, every time we push a change to this project, it will run this on the Ubuntu operating system. You could change it with whatever operating system is supported that you need. You can also test it against a particular Python version. So for your company, you may need a particular version of the project. We can look what's in GitHub. Let's go back to GitHub. And if I type in Python -s version, so it's 3.8. Okay, that's good. So we'll leave this. We'll leave 3.8. That looks good. And then look, we can do a make install, and we can do a make lint, and you could even write some tests as well. Let's take this out for now though, because we didn't add the test thing. We'll just say basically linting code checks it for errors, and I'll even put a note here that says checks for errors. There we go. And even the installations will be tested so that we can even put a note that says locked to specific version. So other people in the future can feel confident that they can check out my project and there's nothing to do. So we do a commit. And then what's going to happen is if we click on this actions button again, it will start to test our project automatically. So you can think of this as like a robot or like an assistant. We go here and watch, it's going to set up the job. It's going to run the action, and then it just does whatever steps we tell it to do. In this case, we're going to test those dependencies for our project, which is PyLint, NumPy. All of these get installed in here. And then we see, hopefully everything is okay. And we have a problem. And this one says format code. It says cannot format. So we have some kind of a problem. So what we can do is we can go back to our project here. This is good because it shows us there was some kind of a problem in our code. And so if we go back here, we can look at the Makefile, and you notice how it says format. Maybe what we can do is only format the code that we know works, which we know that this piece of code should work because we just tested it. So let's just change this. And all the formatting does is it just verifies that our code looks okay visually. And so I'll show you, we can run this ourselves. So if we say make format, and then we look at this piece of code here, it will just clean it. It will just clean it up a little bit. it'll just make it look a little bit better. But it's a good test to run because it will just make sure that our code doesn't have some kind of weird error in it. So both I'm checking for syntax, but I'm also checking the style so that the code looks good. And so now I can push this change because I made two changes, right? We changed the makefile and we changed we formatted the code, so we can do both. We can say git add makefile, git add greedy random start. There we go. We can say adding fixes, and we can push this change, git push. And then once we push this, well, we have to do a git pull. Sometimes because we pushed the GitHub Actions remotely, I have to first pull this down, and then I can say merge the branch, and it will just pull in those files for the build system that I just set up, and then I can do a git push. There we go, git push. And so now if we go back to this project, it will build again, and this time we should be able to build this project successfully. So this really is important because now, as I mentioned, other people can feel confident they can run my project. It can be very complex to run other people's code because they did too many things that are, hard to know what they did. But with this, they can literally see the installation works, the syntax works, and actually the code is formatted in a pleasant way. And we can also go here and we can click this and we can say create status badge. And all what this does, and I'm going to copy this, is it allows us to let other people, maybe future employers, maybe universities that are looking to hire us, or whoever, it will show them that we know what we're doing and that we care about the quality of our project. My recommendation would be any portfolio project that you build, especially for if it's on your resume or application for university or for like applying for a job, that you have something like this where you show that you have tested the quality of your code. And if you see here, look, we can see, look, the test now passed. It just shows that you care about the quality of the project and that other people can see that the code will actually work. Otherwise, it's very difficult to know that the project actually works. So this is a great idea to include in your project. So then once we have this set up, what we could do is maybe look at other pieces of the project and see if we could we could build some other solution, right? Because a lot of times when you're working with an organization, they may want you to maybe take something you built that's a prototype and make it a little more complex so that you could deploy it as an application. So what we could do is we could turn this into a web service. So we could take this algorithm and actually convert this maybe into something like a microservice for a web framework. So what I can do is go back here and we can say, well, how could we do this? Well, what we could do is we could make this into a library, right? We see this is iterations. This is the greedy path. So I could try to kind of put this into maybe a microservice. And so to start with, I'm going to build something called, let's build one called app, like right here, .py. And inside of this app right here, I could start to build out some kind of a web framework, and I'm going to take some code that I had earlier from FastAPI, and I'm going to see if I can get this working. So if we have FastAPI is right here. Code fast. There we go. FastAPI. The way FastAPI works is you can see this is a very, very tiny web service. Maybe first we'll just build this to see if we can we can use this. So I'll go here and I'll go back to this and I'll paste this in. And the only thing that's missing is I need to install the library. And so I'm going to go back to my requirements and I'm going to put in FastAPI. In fact, I could go to that other project and see what its requirements are. which was right here. And we can see that it looks like it needed these two things. So I'll put this back into here. And so I'm going to do the make install again, and then I'm going to find the versions of the packages too. So we'll say make install, which will install these two new libraries, FastAPI and this UVcorn. And then I'll run pip freeze. And we can see that this is the latest version. So we'll do this. And then we also can look at FastAPI, which would be this. There we go, FastAPI. Okay, that looks good. And now that we have these, I should be able to say Python app.py, and notice that it says, look, we can open in browser. And in theory, there we go. See it says Hello Duke. It's like a very simple web application. And let me just go back here. Where is it? Right here. Let me close some of these other windows so I don't get confused. So notice what it's doing is it's running on port 8080. And so if I go here, we could change this. We could say, hello, greedy algorithms, like this. And then notice that if I save it, if I close it and I start it again, we should be able to close this and we can test this thing out. And look, here we go. Hello, greedy algorithms. Right. So we have something working. So it depends on how much work we want to do in building the other piece of code in there. I think an easier one for us maybe to build first would be to use something that is called a greedy coin, which is something that would return back the correct amount of change. And so I think I have this somewhere here, greedy coin. Let's go back here. Let's find this. Here we go. Here's also a greedy algorithm that all it does is that we can call it and it will return back the correct amount of change. Right? That's all this code does is it returns back the correct amount of change. This one is a little bit too complex. I think I have maybe a simpler one that I can do. Coin. Let's see, lambda. Let's see if I can find a simpler lambda function that we can use that's a greedy coin algorithm. Or Flask, Beanstalk. Maybe this is one I can copy some code. Flask. I'm trying to find a good one for us to use. Flask change. Here we go. This is a good one. This is the one I'll copy. So I just need a function, basically. I just need this. I just need a function right here. That's all I need. So I'm going to just copy this function so we can use this in our application. And I'll go back to here. And so I can even put this inside of this right here. Like we can just say, in fact, yeah, we just say this. We just say change. It says calculate the result and store the amount and change. That looks pretty good. And we can just say get, and we can leave this add function in here if we wanted to, or we can make it into a change function. Let's do that. We'll just say like mk or change it. How about that? Change it. And we'll do this. We'll just say change, and then this would be the dollar, and this would be the cents, and we can just say int would be dollar, and this would be cents, and we just say make change. And this should basically take I can look at my other piece of code here. What did I do? So I did change float. yeah, I would need to do something like this. So we'll put this inside of here. So we'll say amount is equal to $cents. There we go. Result is equal to change floats amount. And then all we do is we return back the change and we put the result in. So in theory, this should work, and we can use our greedy algorithm to do it. So let's run this. Name dollar is not defined. Let's see, line 34, change it. Number, oh, I see. This would be dollar, and this would be int. So we have to declare this an integer like that. Okay. And now we run this. Okay. So this might work. So now if I go through here and I'll put in change $1.74. There we go. Right. We have like a greedy algorithm. So the way this greedy algorithm works is that it always starts with the largest numbers first. So the largest coins. And it goes through, and as soon as it can't make change, it takes the next largest coin, goes through, can't make change, takes the next largest change. So this works. The intuition behind this is very similar, right? In that if we look at this algorithm, it just start with something that makes sense, right? Again, in the case of the greedy, the cities, you start with the shortest path. In this case, we're building some software potentially that needs to be conservative. Like we don't want to just give everybody pennies back, right? There would be too many change. We want to minimize the change. So we start with the largest coin. And once you've exhausted, you can't give somebody coins anymore that are 25 cents. Then you go to the next biggest coin. And then you go to the next biggest coin, right? Until you've exhausted all of the possibilities. So again, very kind of intuitive. And what we're going to do is we can now deploy this as a microservice. And the reason that a lot of times business intelligence or business analytics or data scientists may need to do this is that the people in their company may ask them, hey, look, this is really great. You come up with this algorithm, but how do we put this into production? So you would build something like this. So we can keep building on what we built before. So let's go to this Makefile here. And let's add the lint for the application we just built. So let's just double check that it looks okay, right? This is the idea: is the linting. We'll just check to make sure that we have good syntax, and we go through here, and we say make lint, and let's see, does this work? Ah, there we go. We have a good project, and so if I go through here and I say git status, we can say git add makefile, git add the requirements, and I can also say git add git requirements and then app.py. Now there are these two files that are annoying, and so what I'm going to do is I'm going to edit my git ignore, which is, we may not even have a git ignore. I'll create a .git ignore here. Ignore. So this is pretty common with projects, is that you put a git ignore. In fact, I'll find one from another project, and that way that you don't check in junk files that will cause problems. So here's a git ignore, and I'm just going to copy this whole thing, and I'll just go through here, copy this whole thing. And once I go to this, we can just paste this in. And now if I type in git add.gitignore, this should be good. And if I do git status, notice that those other files just went away. So we're making our project a little bit better. And I'm going to say commit, adding basically a greedy coin algorithm. There we go. And I'll go ahead and push this code. We'll do a git pull. And anytime I make changes remotely, I have to do the git pull again. and then we can say git push. And now if I go back to GitHub, if we go back to GitHub and I go to OR, there we go. I don't know why that didn't show up before, but now it does. Maybe there's so many repos it just didn't show up. But basically, I click here, and now we have this thing checking our microservice project. Great. Okay, so we have now the ability to operationalize our code and put it into production. And this is a big emerging trend in many companies, is they call this operationalizing their code. It could be business intelligence you're operationalizing, or it even could be machine learning, right? And that's why there are a lot of people interested in ML ops or any kind of operationalization. It could be a machine learning prediction, or it could be, in this case, just an algorithm. So how would we get this into production? Well, fortunately, there are some technologies that make it very straightforward to put it into production. And so what we're going to do is we're going to use AWS to put this into production. And so I will close all these, leave this window open, close this. And so the first thing that I will do is I will go to AWS, and there's a technology called AWS App Runner, which is right here, AWS App Runner. And a lot of the students I teach at different universities, we use this particular microservice a lot. In like machine learning classes, we use this framework called AWS App Runner. And the reason why I like to use it is it's very easy to use. And the reason why is, you'll see, watch, if we go through here, we say create service. And now you have a couple different choices to deploy our greedy algorithm into production. We could use something called containers, which I think if we have time today, I'll cover this. But we'll start with this called source code repository. And if you go to source code repository, we can select the repository that we want to deploy from. And so as long as it has the ability to have the microservice code inside of there, and we have already had basically tested out locally, it should be pretty straightforward to deploy. So I'm going to look here for the OR repo. We'll go to this repo, scroll down, and let's see, NOP. So it should be before P. There we go, OR. That's the repo that I want to go to. And I could even, if I wanted to, pick different branches. Now, one of the really neat things about this particular technology is that you can either manually deploy the changes, or you could select this option. We won't do it for now, but you could select this option, which means that if many people on your team were building lots of algorithms and changes, that every time you made a change to your repository, it would automatically push that change into production. And so this could really be helpful for an organization that maybe every day you come up with new algorithms and you need to deploy them to production. You just click this button, and they just deploy. They just go into production. So we're going to use this, though, the manual. And really, this is very straightforward to get to run. All we have to do is select the language. We're going to say Python 3. We pick this language. Now, there's only a couple commands that we need to run. And I believe the first one that we need to do is just pip install -r. So we just need to make sure that the packages are installed. So we'll do that. We'll say pip install -r requirements.txt. Now, I don't remember. I think it's pretty simple, the command, but let me look at another project I have to double check. I'm going to go to another project I had deployed and just see which command I deployed. I think microservice. Yeah, I think that would work if I remember correctly. Yeah, I think that should work. So I'll just do Python, and I think we called it app, if I remember correctly. Over here, it's called app. I think it's called Python app, and Python app. That should work. So we'll try that Python app just like that, and we have to make sure it uses the same port as our code, which this is using that port 8080. There we go. and we just say next, and we can call this change machine here. And that's it. That's the only thing we need to do. You could change other things if you wanted to do advanced things, but we can just leave it default and say next and then do a deploy. So this will take maybe a few minutes to do a deploy. But the reason why I like these services is that it really is a very straightforward way for someone to maybe first you develop the logic. So it could be the traveling salesman problem. It could be greedy coin. It could be machine learning. It could be natural language processing. It could be whatever it is you want to build. You build into a function, test it out, make sure people in your company are able to use it. Once you've got that working, then do the thing which I just went through, which is get the Makefile set up, make sure there's some kind of testing. This is called continuous integration. So you make sure that the code has good quality and that it will constantly be checked for quality, and that you've locked down the packages. Once you've done that, then you're ready for the next step, which is called continuous delivery or DevOps. A lot of people are using this word DevOps, and the reason they use DevOps is because it refers to this concept of basically being able to continuously deploy your code into production. And so for businesses that need to move quickly, a lot of times they do need to be able to move very quickly and put their algorithms into production so that other services can use it. And so once you do this, then you can use a high-level framework like AWS App Runner here. And this is one of the really powerful things. So this could also be something that you may want to consider for one of your projects, as well as not only do a write-up that talks about what you build, but maybe also deploy microservice and then push that into production. And then you can show people that you also know how to build these web services. And these kind of skills are actually very in demand right now. And a lot of times you'll see this, these kind of skills, I would say data engineers and machine learning engineers are the kind of people that use these kinds of things that we just built, and they get paid very well. So let's just let this wait for a second, and once this is running, then what's nice about it is we can easily test this out, because it will come with a fully encrypted URL, HTTPS URL, and also it will show us all of the logging as well, so we don't have to make dashboards or anything. It also will come up with metrics that will show us things like, what is the performance, and even further, if you were building this into a commercial service, you could select custom domains, and you could actually give it your own custom domain. So you could register a domain, put it on top of here, and then build like a software as a service company, all just with this one piece of technology. So these kinds of microservice technologies are very exciting because of just how quickly you can build something and put it into production. So this should take just a second here, and then we'll be able to test it out. So now we can see, look, the logs are running right here. We can see health check is performed. It checked 80/80, so that's a good sign. It was able to pull so it starts from here. We say service creation started, operations in progress. It pulled the code, it built the code, it provisioned the instance, it did a health check on port 80/80, and it looks like it was successful. So that's a good sign. And I think if we just click this button, it may, there we go. It's already running. And one thing to point out about this service is that we can now tell it to do the change, right? So we can say change, $10.45. There we go. It says 41 quarters and 2 dimes. Now there's another thing that this technology has that's very powerful, and it's called, it has something called Swagger. And if you add docs to the route, that what it will do is it will give you a web form for the API. So other people in your company maybe the data scientists or the product managers, whoever, they don't have to write code or even know about web technology. They can just click this button and they can just try out your service. So again, if this was, for example, maybe a machine learning algorithm or some other business intelligence algorithm, this could be a very, very simple way to build a web service for other people. So look, we could just click this, try it out. And you can go here and we can say, $3.45, and let's go through and we can execute it. And look, it came up with our response right here. And it even shows you if you want to call this service in a different way from the terminal, how you could do this, or what the web request URL is, and all of the results for this. So pretty nice service for building things into production. And you can see here, it all started with the very beginning, which is you build out the code space, you test out your code, prototype it, make sure it works, push that into production, then go to this microservice technology, and then push it into production, test it out, and you're good to go. So this could be very similar to someone that's a machine learning engineer. Your first day of work, this could be very similar, or even every day you would do something like this. So there is, I would call this the logic. And logic could be machine learning, it could be business intelligence, it could be data engineering. You could have lots of things. We could call this AI, right? Because we did natural language processing with AWS. You could do ML, you could do greedy algorithms. We'll just call this algo, whatever it is you want. And so now we have to decide, well, what do we do with this, right? We need to serve it out. Now, in some cases, you can just give this to the customer or to people in your work, but it does appear that there is a huge demand for people to be able to take this and do something with it. And this is why it's important to have the ability to build software in a cloud-based environment. And so it doesn't matter which cloud, it can be any cloud. But most of the time, I think people are building things in a cloud-based environment. And once you build it into a cloud-based environment, typically what is going to happen, I think we're going to see this 2022 and beyond, is that most likely it will go into a container registry. And this is what I'll get into next, is what is interesting about a container is it's a package. And so it fits very well for the logic, right? You can think of a logic as like maybe something you're selling, right? You're selling a bunch of stuff, you put it on a ship and you put the ship somewhere else. Same thing, the logic will go built in the cloud, goes into a container. Once it's in a container, it's easy to push it into the web, right? And this would be something similar to what we built. And so if you want to get into machine learning, data engineering, business intelligence, this workflow, logic, cloud, container, microservice is very good skill to have. So let me show you a couple of the things here. So if we go to a project I was just working on the last few days, which is a C# based web service, that I built some things that may be related to what we're going to cover. But the main thing that I wanted to show was, if we scroll down here, is that if we look at a service like AWS App Runner, you can see that you add the source, you configure the settings, you review, and you receive a secure URL. And so you also can give it a container registry, and this container will have the full package. So you don't even need to know what the language is. It could be in any language. And what it looks like in practice is this. You build a cloud-based development environment, you push it to ECR, this then gets hooked up to App Runner, and then you can test it out in the cloud. So this works very well for many of the things that we've already covered. So let's do this. Let's do this next. So let's build something like this next. And so what I'm going to do is I'm going to go to AWS and I'm going to build a cloud-based development environment. And so what I can do is basically, I think I can just use maybe one I've already set up, which is this AWS Copilot setup. And I'll show you the structure for a different language, but it doesn't really matter. It's similar to Python because the concepts are really the same. But the general idea is that you build out your application, and then you have your container file living in the same directory. And so the nice thing about this kind of a project is that, again, this could be in any language. This one happens to be in C#, but if we look at this program, it's a very simple program. It's even simpler than the Python program. You could build together some application that does something. In fact, let's go ahead and run this application just so you can see what it looks like. I'm going to go into this web service here, which is .NET 6. We'll go into web service. And then to make it run, I think we just say .NET run. There we go. We say .NET run, and then it will create a URL for us, and then I can just curl that address, and we can say, I think it looks for hello, and we can say bot or whatever. There we go. Right. So we see that this is returning back our result. So the trick is now, since I've already got this set up, we won't waste our time building all this out, is that what we can do is I can build out a container and push this into a containerized environment. And so in order to do that, what I'm going to do is I'm going to look at that other project I had, and I'm going to refer to some of the documentation. So the first thing I would need to do is I would need to make sure that I can build a container. And so this is the command to do that, which is right here, docker build, and then we can just test it out. So if I go to here, let's close this, let's close this, let's close everything. Notice that this is the magic file, and it works with Python, it works with C#, it works with Ruby, it works with the R language, Julia language, any language you want. You have to have a file called Dockerfile that just packages our whole project up. Once you have it into a file, we can go like this, and you can build it out. And it just builds a localized environment that contains both the runtime and the application. Here we go. So we push it. And then once that gets started, then all I need to do is then basically run it by using the Docker command, which I'll do next here, which would be this command. And so now we know it built, and I can type in Docker image ls like that. And if we scroll down, let's just make this bigger. If I type in Docker image ls like this, we should be able to see that. Anyway, it's right here. This window is for some reason not letting us. I don't know why it's acting so strange, but basically it built it. Let's clear the window, Docker image ls, and it should be at the top here. Anyways, it's this image. So now the next thing I'm going to do is I'm going to run it by using a Docker command. So Docker will then run this containerized application, and it will build it all inside of this one package. And once it's packaged, then I can just do the same thing. I can just open up a terminal, and I can notice that this is exposed on port 8080. I can just say curl And I think I can just do localhost. Yeah, just like this. I can just run this command. There we go. We know that it works. And now I can push this into the cloud-based container registry. And so if we go to the console of AWS, they have something called ECR. These things live in all cloud environments. Google has one, Ali Cloud has one, GitHub has one, every cloud has it. All we would need to do is just create some repository, and we could call this, maybe if we want to keep the same name, we can call this greedy algorithms, just like that. We'd say, okay, great, we have greedy algorithms. We're going to push our code here because we're going to deploy it later. And now if I look at this, I just click this button. All I need to do is select this command here that says view the push commands. And then I just need to type these commands into my browser, into the other project window. So I'm going to grab this first one, and then I'm going to go to this environment, and I'm going to stop this other window, and I'm just going to type these commands one by one. So first one is login. This lets me log into the container registry. Step 2 is it wants me to build it and call it this name, because it's going to need to correspond with the same name as the registry. There we go. It built it very quickly. The next thing that we'll do is we'll give it a tag. So this basically labels it so we know what the version is of the container. And then the last thing is we push it now to this registry. So we just grab this last step. Here we go. And then we push it to the registry. Perfect. There we go. And this should be really, really quick. This should push this into the container registry. There we go. Perfect. And now if we look at the ECR registry window right here, grab this, push this, there we go. See, we have it pushed in the container. So this is really this works with any language. And what's great about it, it's like a shipping container, right? Where you put it onto the boat and it's all packed full of things, and then you can bring it somewhere. So now we can use the same approach that we used before. There's nothing really different about this. All we need to do is open up another window, and we can go to the AWS App Runner again. And if we click on AWS App Runner, we just make another service. In this case, this service will use the container registry instead of using the source code. So it's even easier to deploy our logic. And so I would select Amazon ECR. I would go to Browse, and then I would scroll down here. Here we go, greedy algorithms. There's our code. That's it. It's that simple to deploy. And I could even do automatic now, because every time I push a new container, it would deploy the new changes. So if I change my algorithm or change my machine learning model, whatever, all I need to do is push it to the container registry, and the rest will deploy automatically, right? Which is pretty amazing. And then I would just select, use some role, go next here, and we'll call this greedy algorithms, like that. And now this is the part that's important, is it must match with the service. Now, if you remember, we had ours running on port 8080. That's it. That's the only thing you need to do, is make sure that the port's the same. And then we do the same thing. We create and deploy. So it's even easier than in the case of when there was the source code. And again, this works with the Python language, C# language. It works with literally any software development language. You containerize it, and then if every time you push a new change, it will deploy this to production. So what will happen, that's really amazing, is that once this runs, we should also be able to run these same commands. So if we went back here, what you'll see, this is what we did. So we wrote our code, we pushed it to the container registry, we had the version of the software, and then once it's inside of here, it can either run inside of AWS, it could run on maybe another data center for some other company. It could run in something called Amazon Kubernetes, EKS, or it could run in ECS, or it could run in the App Runner, which is the one that we set up. And then this is what we did. We went through here and we created a new repository, and then we went through and we pushed all of these commands just like this. And then the final thing that we did was we made sure that the image was pushed into the container registry, and then we went to app runner. And what we talked about before is that you just add it to a container or your source, you configure your settings, review it, and then you should receive a secure URL. And this is exactly what we did. We went through here, we went to the container registry, we picked ECR, we got this. And then this is what is really powerful, is that if you select this, every time you push a new version, right? You saw how easy it is. You just tag it, you push it, then it'll deploy that. Maybe it's to your customers, it's maybe some kind of recommendation engine that, you know, tells them the best movies or music they should listen to. And then finally, you would name the service, and you just need to select the right port. That's it. And once you have the right port selected, then what will happen is it will go through and it will push this change. And again, it takes a few minutes to push the change. And then you can either call your web service via a terminal inside of AWS or some other place, or just go to it in a browser. And so the idea here is that this workflow will work for, this is, I think, a very effective workflow for doing data engineering, machine learning engineering, ML ops, which is you build in the cloud, you push to the container registry, you deploy to a microservice, and then you give it basically to your customer. And that's really it in a nutshell. Now if we go back to App Runner, let's see if we can get this running. We see the service is being created, and this should just take us a second here. Here we go. Service is created. The service operation is in progress, and look, we can see that it looks like it's already deployed. So if I click on this, maybe it's not deployed yet. Maybe it's we need to let's double check. Hello. Yeah, it looks like it's still being created. Performing health check. So I don't think it's come back yet. Once this is successful, but notice that it's provisioning an instance, and then it pulls the image from that container registry. And so the nice thing about this kind of a workflow is that if you have a working in your cloud-based environment like Cloud9 or the GitHub Codespaces or your desktop, you can basically be assured that you'll have the same experience when it's deployed into a cloud-based development environment. So let's just give this a second. This should be, there we go. Health check is successful. So now I believe if we click on this link, it will work. Not yet. Oh, there we go. Homepage. Perfect. And then if we go through and we say something like, hello, Bob. There you go. We see our service is working. So containerized deployment is also, I think that the future for most people doing this kind of data work. Now, the other thing we can do is, as I mentioned earlier, is that there is something called CloudShell that I like to use. And let me just show you how this works. Is the CloudShell is just a terminal where if you're going to be operating with a lot of different web services or different environments, most cloud providers have something like this. This is a great location to just run some kind of a command against your code. Like it could be a curl command to your web service, or you could do some kind of operation. And this is what I typically will do if I'm going to, test out one of my services. Is I open up a shell. It takes a couple seconds for it to load, and then once it loads, I can actually make commands against it. So just give this 1 second. For some reason, this particular CloudShell, there we go. Finally, it's wait. So then I would just go through here. I would do a curl command, paste in our service. There we go. Right, and I can change it, whatever we want to put. And now we have an existing web service. So hopefully this feels pretty intuitive for you to use these kind of ideas to build your own microservices. I think we have a little bit of time. What I could do is I could try to take our service and also containerize it. Why don't we try to do that? Because we have a little bit of time. So what I'm going to do is I'm going to look at a FastAPI service that I already built that has a container. So see this is a container for a FastAPI service. So what I can do is I'm going to go to my Cloud9 environment real quick. Here it is right here. And I'm going to check out one of my GitHub. I'm going to check out the operations project, and I'm going to change it real quick. So where is this OR? It's funny how it doesn't show up here when I search for it. There we go. I have to do it this way. So I'm going to go to this project. I'm going to click on code, and I'm going to select this repo. So what we can do is I can just go up a directory here, and I can just say git clone, and I can also check out that Python project I was just working on. So we'll say git clone, go to here. There we go. We got this project, and I'm going to create a Python virtual environment real quick, and then we can do this, and then I can source it. There we go. And now what I can do is I can go into this project, and we can do the same kind of a thing. We can containerize it. Pretty straightforward to containerize this project. All I need to do is create a Docker file. So we'll just say Docker file, just like that. And then once I have that Docker file, I should be able to copy that other project that I had, which is this Docker file. Let's copy it. It should be very similar. I just have to change it a little bit. So what I'm going to do, this looks okay. This looks okay, but remember we called it app, right? So I need to change that. I need to change this to app. APP, that looks good. And then that looks good. And I think this is it. That's all I need to do. So basically I can do a similar command, and I'll just look at this project and see what commands I did. So I think I just need to do docker build. Let's try this. Docker build -t. We'll call this FastAPI latest. And I think that's all I need to do is something like this, and dot. There we go. So build. Now we're going to build this container. We'll just double check that this works. Again, it should be very, very easy to build. That looks pretty good. Let's see here. Still working. Okay. And then let me see the command. It should be something like this, which is, whoops, history. So we're going to say docker run, and we'll say FastAPI latest, just like that. Docker run from Flask. Oh, let's double check. Maybe I messed this up. What did I? Oh, I didn't copy. Let's double check here. Docker run FastAPI latest from main.py. I'm not sure why. I may have messed something up here. So make dir app copy. Oh, because I already had a file maybe called app. Copy app.py to app. Pip install. Oh, I'm calling the same. See this? I call main when I should call app. There we go. There we go. Perfect. App. So I just need to build it again. There we go. And now I can run it again. And I'll put this in the README so that other people can get access to it. There we go. So now it's running, and then I could do the same thing. I could just say curl, and we just take the name of this command like this. Curl HTTP. Let's see, localhost. Oh no, curl. That's what I need to run, that command. It's always good to look at the output of what's running. 8080. There we go. Greedy algorithm. And then if I did the change, right, I could do change $1.34 or $1.34. There you go. 5 quarters, 1 nickel, 4 pennies. Perfect. So we got this thing running. It looks good. So I'll put these commands inside the README file so that other people can get access to it. We would do this. We'll say container to run container. We would just do this. And then we would do the Docker build, which would be history, which would be that. So now, pretty easy to push this to ECR, right? We already know how to do this. We just go back to the ECR environment. We type in ECR, container registry, and we'll make a new one, and we'll call this one greedy FastAPI. FastAPI. There we go. Pick this, and we'll create it. Once we see it, we can select view push commands, and we just do the same commands. I think I've already logged in, so all I need to do is just do this. I just push this first one, which is, we do this, Docker build, and then the next command is I will tag it, which is right here, and then I push it. And I take this command, copy it, and then I push. And it's very fast because I have a really powerful machine. You can pick really powerful machines with Cloud9, so it pushes very quickly. And there we go. Looks like it's almost done. Perfect. Okay, so now I just go to App Runner. We go again to App Runner, and I make a new service. And I say container registry. I select this, and I find FastAPI, greedy FastAPI. There we go. I click this, automatic deployment, go next. We'll call this FastAPI greedy. Pick everything the same. Remember, it's port 8080. That's fine. We go through here next. That's it. It just takes a second, and we create and deploy. So it really is very easy to containerize applications and push them. And it really takes something that used to be very complex and actually makes it very simple to build applications. So we can wait for a second, just give this a couple minutes, and then we can test it out. And if it works, then we've also containerized the FastAPI service as well. And I can push those changes while we're waiting. So I can just do this. I can say get status to run container, and then I can say to push to then push to ECR. We'll say that A, and then B, deploy via AWS App Runner, like that. There we go. And so then I'll say get status. This should show me that I changed the README file as well as the Docker file. Right, they're both changed. So I'll say get add star, get commit, adding Docker container, push. There we go. And we can go back to App Runner. Hopefully it's pushed. It's close to now. We can refresh this. Service started. It's ready to go. It's creating a pipeline, and then it should pull our container in a second, and we can test it out using the same method that we did before. We should be good to go. There we go. Income, traffic, routing. There we go. And so now I could go to docs. Is it doc? Yeah, docs. There we go. There we go to docs. There we go. Our application works. And I can say try it out. $2.45. Execute. There you go. So containerization is really a very good skill to learn, and it's very straightforward if you can practice it.